Hi everyone. Today I'm recording this video to show you my solutions to homework 3. So the first one is a heap sort. So for the heap sort, there are two things you have to do. So number one is Heapify. So for the Heapify, usually we are starting from a index I, and we know this index I needs to be fixed. So how do we fix that? We have to get the left child and the right child. And then we want to make sure that the value on the index I is higher than the values on the left child and the value on the right child. If it is true, well, that's terrific. If it is not true, and then we have to find one thing. So that is, for our current node, which is I, and then on the right, this is the left. So on the left child and the right child, well, on those two values, and then our question is which one is the largest. So if we do comparisons and then we find, okay, so the right one is the largest, and then what we want to do is we want to swap those two values. So once we swap those two values, this guarantees that the largest value among those three are on the top. And then, so for example, and this means, the right value will be on the root. So this R is supposed to be here, and then the value that used to be I will come down. And after that, is our work done? And the answer is no, because underneath the I there will be another sub portion of the heap. So you have to fix that too. So the last step is we have to do a recursive call to do a heapify for this value on the new location. So this is heapify. And after we have the heapify, the next one is we want to do a heap sort. And for the heap sort, the process will be, we are going to do a iteration from the end to the beginning of the array version of the heap. And the array round, what we want to do is we want to swap the very first value, which is the smallest value, and to the very end. So every time we do a swap, and we want to reduce the size of the heap by 1. So after we do a swap, and then the last value in the array version of the heap will be excluded. We don't want to look at this value anyhow, and then we want to do a heapify to make sure that the value on the very beginning of the array version of the heap will be put into the right place. So we still have a valid heap, and we are going to do this again and again. So this is a heap sort. The next one. The next one is a weird question, and we call that Dr. Song's weird max. Okay, so how can we do that? So let me give you a very quick review on how I designed this question or this algorithm. So if I have an array, and then we divide this array into 3 portions. So the sublist 1, and then we have sublist 2, and then we have sublist 3. Okay, so we have one big sublist, and then we are going to divide that into 3 sublists. And then every time, what we want to do is we grab 2 of them, and then I do a string max. So what we are going to do is, we only grab 2 pieces from those 3. So recursive function call 1, and this one, and then recursive function call 2, recursive function call 3. And then what we do is, this is sublist 1 and 2. And we combine this next time, we combine sublist 1 and 3, and then we combine sublist 2 and 3. Okay, so every time we want to combine 2 of the lists, and then we want to do a max. So there are going to be 3 recursive calls. So, the overall idea is to find the max of this array. I divide this array to three subarrays, and on those three recursive calls, I'm gonna find I'm gonna use the recursive call to find the max of the combined version of the sublist 1, 2, and then the combined version of the sublist 1, 3, and combined version of the sublist 2 and 3. Okay, so and what is the base case? So in my solution, I did two base cases, and the number one is if there's only one value in a subarray. Well, I can't even divide that into three pieces, so I'm gonna just grab that one. And another case I use is, well, what if there are two values? So on the two values, if I want to cut them into three pieces, one subarray is going to be empty, so I don't like that. So I just grab those two values and do a comparison, and whichever higher is going to be returned. So those two are the base cases I considered. And otherwise, what I'm going to do is I'm going to try to divide this list into three subarrays, and then I'm going to do some of the some recursive function calls. So those are the three recursive function calls. Okay, so this is the code. Well, and the hardest part is not on the code itself. It is on how do we figure out the recursive version of the Tn. So what is the Tn? So we can see is the Tn will be the cost for us to find the max of this array. And to find this array, and then we divide them into three pieces. And then for those pieces, well, they are, we are going to try to find the sublist 1. And then we are going to find sublist 2. And then we are going to find the sublist 3, right? So for those pieces, well, I think they can be considered as primitive steps because we didn't really create a different array. We are just trying to grab a portion and say this is a subarray. Okay, but the next part, when we are doing the recursive calls, we are adding the subarrays together. So for example, we have the sublist 1 and sublist 3. How do we combine them together behind the scene? In this case, so we are gonna grab all the values here and all the values here, and then we are gonna copy them into a new location. So in other words, when we are combining them together, and yes, it is a linear process because we are grabbing all the values in sublist 1, all the values in sublist 3, and we paste them together. So when we are doing the list concatenations, it is a linear process. So, well, and let me write down this part. So every time we are gonna adding 2/3 of the array together. So that will be let me do this way, 2/3 of the array, and we are going to do them to add them together, and then we are going to combine this 3 times so that we have those 3 subarrays. So this is the additional cost. And then for this Tn, Tn is 3 of the T, and then 2 divided by 3n, and then plus the cost of combining the subarrays together. So what is this? So let me write it down in a better way. So it is 3t 2n divided by 3, and then plus a 2n. Okay, so the next part we want to use the Mass Theorem. So what is A? So A is going to be 3. That is easy. And what is B? So B is what the value that n divides. So B is 3 divided by 2. And then what is Fn? Fn is going to be 2n, right? So this is the A, be an Fn value. And after that, well, remember what is the question we are gonna ask? Well, and we are gonna find the value of the n powers log BA, right? So base value is B, and then what is that? So log BA is gonna give us, so log BA, this B is gonna be 1.5, and this A is gonna be a 3, right? So this means log BA is something higher than n. So I don't have a calculator. I don't know how big this value is, but I have a feeling that for the log BA value, it will be a value greater than 1. And that is enough. And this means, well, n powers log BA is going to be faster than Fn. So this will give you case 1. Okay? So, well, for the last part of this 04 strange max, and your answer should be, well, this recursion is actually a log, it's actually the case 1. So the case 1 is going to be higher than linear. This is the answer. Okay, so this is my solution to homework 3, and I will see you in the future videos. Bye bye.